I'm Dr. Lu-Ean. So this video is just a very short video. I want to explain three examples for you. So from these three examples, you can try to extend your understanding to other examples that you can find in any reference book. So first is the question. This question just asks you to find the three body diagram. For sure, you can try to determine and find the solution also if you want, okay, but always important, the rest is just about the mathematics. So the most important is how whether you can able to identify the components that you need to determine. So from this figure you can clearly see in point A, it's actually the smooth color. So the point A means this is freely move here but cannot move here, right? So you can find you can draw one and A, or you label it FA, no problem. So what is the angle? So here is 45, here means 45 also, you just label it. So this is the external forces, you just remain it. And this is the roller, okay, you can see the roller can freely move here, cannot move here. So you can draw one over here, okay, you can draw your force, and because this is the external moment, this is the external moment, you have to remain it. And for this point, because this is the pin, actually you can go up and down also, okay, but if for this case it's very easy, you can see that it is fixed here, so you can just label the FCD, okay, so you can just label one force over here. For this is the free body diagram, okay. So here is another example how you're going to draw your free body diagram. So if you, this is very important, if you look at these figures, there is no x and y axis label. So however, when you look at this here, when you connect C, B and point A, because always remember, reaction force is created directly go to the point or direction where you apply the force, which means that, can you imagine if I push here, I apply force in this direction, this one upwards, this one would acting downward, correct or not? Okay. So when this up, this down, the reaction force in the opposite direction, where this one supposed to go up, so reaction force go down, this one supposed to go up, the reaction force go down, okay. And you should able to imagine, like for example this point, what is the connect point? For this one, the angle is like this, so your force is here. However, when your point is here, it must be perpendicular to the direction, so NC it must be go up, correct? Okay, I hope you can understand. Always remember, reaction force is perpendicular to your the point, or actually is directly towards to your point. So you should try to imagine this one go up. If I push this one has this direction, no problem, because of this connect is directly 90 degree. And this one also, if my point is like this, directly over here, right? But for this one thing you have to be careful is because the point is like this, so your force is here but not here, okay. So one important thing for this figure is you can either use vertical and horizontal for your reference, or you can label your x and y axis, okay. Always remember, your x and y axis must be follow your right-handed rules. That is the reason why you cannot assume here y positive, here x positive, because here x positive, here y positive is according to your right-handed rules, okay. If you want to put y here, your x must be go to here positive. Therefore, I said you can try, if that is not given by the question, you can provide your own axis label. But if you want to do so, you must label it. If you don't label it, I don't understand where is your assumption, okay. So I hope once you obtain this called free body diagram, you should able to find to solve, because it's all about the mathematics. The rest is all about mathematics, right? So another example which is important concept that I want to share with you is, okay, first for sure we have to draw the free body diagram. This is a free body diagram because this one can move up, down, but cannot go here. So I have only one reaction force in AX, but this one cannot rotate, so I have a reaction moment. Okay, so this one is the external one, so remain. This one, roller can move here, can rotate, but cannot move here, so I have only one, and B. So if I want to find, it's very easy. I use summation Fx equal to 0, summation Fy equal to 0. I can easily find my Ax and B. Okay, so this example can let you know that in certain cases why we can avoid some force is because some force, if you find, you will get 0 also for that force, which means that if certain force that you're able to find, and based on your understanding, you know it is 0, you cannot really label it also, because you can get 0, so it will help you to simplify. But if you don't know, you just remain it. Okay, so this thing always remember, I hope you still remember, when you take a moment, you can take from any points that you like. So for this example, you can take moment at point A or you take moment at point B. However, no matter you take A or B, the most important part is you must understand, if you take at point A, all the distance must be now referring to point A. If you take point B, all the distance must now referring to point B. And also you have to be very careful, are you going to use scalar method or vector formulation? Scalar method is FD, vector formulation is RF. So what is so important about FD and RF, it would help you to decide your direction carefully. Okay, so for this one, if we look at FMA, MA equal to 0, then I still write MA minus 900 times 1.5 to 500 is the external one, 900 is the MB. So I guess student will ask why I still need to write MA, because you will ask like, I thought you said taking at point A, we no need to consider point A, right? Okay, this is the wrong concept. This is only correct because if you're taking moment at point A, you no need to consider components at point A, and that is only apply for force. The reason is because if you take moment at point A, the distance between the force at point A and point A is 0. Understand or not? If I take moment of point A, all the force must now referring to point A, their distance. So the distance is 0. Therefore, I no need to consider because I know the answer will be 0. However, for moment, still remember previous video, the moment is freely from any point. It's free from any point because for a moment, the distance already considered. So even though you're taking moment at point A, if there is any external or reaction moment happen at point A, you have to include it also. So it seems like this example, you are writing MA. So this one, you must very careful because you need to assume your direction. For this condition, I follow MA, so I anti-clockwise positive. So the rest, this one, I need to become negative. Okay, so if you take point B also, okay, you take point B, so you have to consider for AX. However, AX is 0 for this case. So always remember, where you want to take moment, it depends on you, whether it will help you to simplify or make your equation become complicated. So the most important part is when you take moment at point A, you can ignore force at point A because the distance is 0. However, the moment or reaction moment that happen at point A, you cannot ignore them because the moment is free from any points. Okay, here are 3 examples that I want to share with you by using this video so that you can have better understanding before we go to the 3D system. Thank you.